24/7 observation is not easy, sometimes even impossible for most people. And that's the beauty of using microcontrollers like Arduino, which help us to automate the whole process of keeping an eye on sensitive things even when our eyes are closed. Hi everyone, this is Majid, Digital Creation Specialist at One Public Libraries, and today I want to show how you can set up a project to monitor the temperature and make sure it's perfect for your beloved flower. Let's dive in. Suppose I wanted to protect a flower sensitive to temperature, and if the temperature goes over 35, it may damage the flower. So I wanted to keep an eye on the flower, make sure that everything is under control, the temperature is 35 or less. So this is the project. If the temperature is 35 or less, a green LED will be turned on all the time. If the temperature is over 35, so I want the green LED being turned off and another LED, a red LED, turn on and a buzzer turn on. Make some noise, let me know that, oh, there is something wrong, I need to take care of the flower. With this project, which again we are using Tinkercad, what we are going to learn. So we are going to learn how to read an analog input by using a thermometer or another heat sensor. It doesn't matter, as long as the sensor can detect the temperature and turn the temperature to the voltage, it works for us. So we are going to learn how to read that information from an analog input. We are going to learn how to create variables, put that information in the variable, use that variable inside of our project, and then use if condition. So again, I'm on the Tinkercad circuit and I already click on create new circuit and change the name of the project to temperature monitor. When we are working on a project has different levels, it's better to split each level and focus on that level. So the first thing for this project is we need to get the temperature. So we need a temperature sensor. So I'm searching for that to see if there is such a thing like temperature sensor or not. So go to all component and temp, and it seems that yes, we have. So this is the tool we need to detect the temperature. And another tool definitely we need is Arduino board. So I'm just bringing one Arduino. And the other part of the project is working on those LEDs. But let's see what we need. We need a temperature sensor. And we need two LEDs, one green and one red. So I'm going to bring two LEDs, one red, and always you remember that we need to connect a LED to a resistor to protect the LED, because LED is very sensitive to the current and we need to take care of that. So I'm bringing another LED, just change the color to green, and let's put actually this one here, show you why. So I have a red LED, a green LED, and again I need a resistor, more items here, and another thing I need is a buzzer. So let's search for a buzzer. So now the question is how we can connect these to the board. So for temperature sensor, if you hover around the pins, the legs on the sensor, you see we have 3 pins. One is power, one is V out, mean voltage out, and one is ground. So it's not very difficult to figure it out which one is which. So for the power, we connect the power to 5 volt. Just change the color. Again, when something is connected directly to the power, we always change it to red. The second wire is for the ground, and we change it to black. And the third one, which is the voltage output, we connect it to one of these pins. So power to 5, ground to ground, and V out to A0. It doesn't matter. All of these pins are analog input. Probably it's a good time to talk a little bit about analog and digital and what's the differences between those two.
This is a very simple chart to show the difference between analog and digital wave or information. So as you see, this is a digital wave format, and it has only two steps, step 0 and step 1. So something like push button, you press the button, so it's the step 1, and you release it, it's 0. And that one is analog, and you see that information is continuously, like temperature. The temperature can goes up, for example, around 40 and then come back during the day, and then again go up and come back. Not always in similar, the wave can be going this way or can go with some anomaly, but at the end it's a continuous information. You probably see in electronic project, we mentioned that step 0 or 1, turn on and off, or we talk about voltage. So for example, in most Arduino project, step 0 means 0 voltage and step 1 means 5 volt. So I quickly finished assembling the project because the other part of the project is very similar to the previous projects we already done with Blink project. So as I explained before, we have two LEDs, green and red, and you see as like the Blink project, we connect them to two pins. The anode legs should be connected to the Arduino pins. So I picked number 8 and number 4 for LEDs, but it's totally up to you. The cathode one, the negative part leg of the LEDs, are connected to the resistor. The resistor are here protecting the LEDs. I connected them to the ground pin. And for the last part, for the buzzer, buzzer has two pins, to positive and negative. Connected the positive to pin number 3. Again, you can pick other pins. Even we can pick number 4, that's totally okay, but I separated the connection. And the other leg, the negative leg is connected to the ground. You can pick this ground or any, all grounds are connected to each other. So that's the hardware part. Now this is the time to code the Arduino, and that's the best part, because today we are going to learn two new things. The first one is variables, and the second one is using an if condition. First, variable. As I explained before, we are going to get the information from pin A0, and then based on that information, Arduino will calculate which LEDs should be turned on and when the buzzer should works. So what's happening here, based on the temperature this sensor detects, the voltage on this pin V out will be changed. So that's the information. So we need to get this information, and for that part we use a variable. Let's do this. So we need to get the information from this pin. So we need an input, and we need to put that information inside a variable. So we need this section too. So we need a variable and we need an input. I already created a variable and name it to temp, and as long as for creating a variable, you just click on create variable and you can put any name you want. And as soon as you create a variable, it shows two more tags, set a variable and change the variable, and we are going to use set the variable. So let's go and see what we have here. We have read digital pin, read analog pin, and there are others related to that. So detecting temperature, heat, that's analog information. So we need to pick read analog, or if you go here, it has a specific tag for temperature. Read temperature sensor on pin something. So we put it here and pick any pin here, any analog pin here. So because I already attached to A0, I just leave it as A0. And the beauty of this tag is it's at the same time change the information to the Celsius degree. So we don't need to calculate this. Bring the control. So I'm going to use if condition. I need here to add this tag here. So with this tag, I'm going to connect the information the Arduino get from the pin A0 and put that information inside the variable temp. So now I just need to check if the temperature is under 35 or over 35, that kind of things. And I use this if else condition because we have two sets of data. When the information is above 35, when the temperature is above 35, or when the information is under 35. So for comparison between the information I get and the temperature 35, I'm using on math, I'm using this tag. So I'm comparing the temperature with the number 35 here. So if the temperature is equal or less, then if this is true, then do this. So now we are going to set the output. So here we have pin. We need two of these because we need to manage both pin number 8 and number 4. So if the temperature is under 35 or equal to 35, everything is okay. Just turn on the green LED. So green LED is connected to number 8. Connecting to number 8. Number 8 should be high, and number 4, which red LED is connected, should be low. If it's over 35, then this condition is not true, it's false. When it's false, it jumps to else. So here again, I can duplicate this part, or just as it's very simple and a small part, I bring it here. So if it's over 35, then turn off green LED. Green LED is connected to 8, so it should change to low, and red LED should be turned on. But there is another thing we have to do when the temperature goes over 35, and that's turning on the buzzer. So if you see, we have a play speaker. You can use this play speaker on pin number 3, and use tune 60. You can change the tune here, and here I'm changing to half a second because 1 second is very long for our purpose. So we have to, at the same amount of time we need it here, we need to wait and to stop other activities on the Arduino. You just need to turn on this voice for half a second, and then you're going to turn off. So after half a second, turn off pin number 3, and again wait for half a second. So to me it seems that it's done. We just need to run the project and see if everything works properly or not. So here first of all, you see that the temperature is 25 here, and the green light turns on because it's under 35. I'm going to, yeah, and you see when I pass 35, now we have this sound, and you see that the LEDs turn on too also. So as you see, the project works properly when the temperature is 35 or under. The green LEDs turn on. When it's over 35, red LEDs turn on, the buzzer works. So now we know that everything is perfect around our flower, and if something bad's happening, and Arduino will let us know.
Thank you for staying with me to the end, and I hope you enjoyed watching this video. Please remember to go to One Public Library's channel on YouTube to watch other videos like this. See you soon!